Hi everybody, so in this video I want to continue our work with linear models. And so the example that I want to take a look at in this video is in regards to Somali refugees in the summer of 2011. And so what this article tells us is that because of drought conditions in Somalia, refugees were leaving Somalia and arriving in Kenya and Ethiopia and neighboring countries. And so we're told that as of June, there were 68,000 Somali refugees in Kenya and 54,000 Somali refugees that had already arrived in Ethiopia. And we're told that, at least according to the UN, that there were 1,700 Somalis that were entering Ethiopia each day throughout July, and there were 1,300 Somali refugees who were arriving in Kenya. And so we would like to construct models for how do the number of Somali refugees in Kenya change with time, and how are the total number of Somali refugees that have arrived in Ethiopia changing over time. So the first question might be, well, why should we use a linear model here? And so when we're reading this excerpt from the article, when we see that things are growing at a constant rate, that means a linear model would be appropriate. So if we look at this article, what we're told is that at the moment, the UN indicates that 1,700, 1,300 were arriving in Ethiopia and Kenya, respectively. So since we have this assumption that the number of Somali refugees entering Ethiopia is constant, 1,700 every day, that would be a linear relationship. And at the same time, since we're told that the rate at which Somali refugees are entering Kenya is constant, 1,300 Somalis a day, that tells us that we have a linear relationship for both Ethiopia and Kenya. Okay, so in part B, we'd like to come up with linear models for each of these Somali refugee populations in Kenya and Ethiopia. So let's start with Ethiopia. So in Ethiopia, we know that the slope from part A, we recognize that the slope is 1,700. Since every day, each time we increase the input by 1 unit, the output, the number of Somali refugees in Ethiopia goes up by 1,700. And we also need to know what the initial value, the vertical intercept, is in order to construct this model. So in this case, t being 0 would be on June 30th, how many refugees were there, in this case in Ethiopia. And so we're told that at the start of this period, that there were 54,000 Somali refugees in Ethiopia on June 30th. So therefore, our model for the Ethiopian refugee population, I'll call that capital E, would equal this initial value, which is the 54,000, plus the slope, which was 1,700 times T. And similarly, for Kenya, we are told that initially their number of Somali refugees present in Kenya on the start of this period on June 30th was 68,000. So for this model, for the model for Kenya, we'll call this capital K, is going to be 68,000 plus the slope was 1,300 T. So here we've got our models for Ethiopia and Kenya. And so just comparing these two models, we can see that Kenya starts off initially with a higher number of refugees than in Ethiopia, but the refugee population is growing much more rapidly in Ethiopia than it is in Kenya. So a very natural question to ask would be, well, we start off with more refugees in Kenya, but the refugee population is growing faster in Ethiopia. Is there some point in time when the number of Somali refugees in Ethiopia and Kenya are going to be the same? So that's what we'll take a look at on the next slide. Okay, so let's continue with this same example. So K, we found in the previous slide, the number of Somali refugees in Kenya we modeled was K is 68,000 plus 1,300 T, and the model for the number of refugees in Ethiopia was E is 54,000 plus 1,700 T. So part A, we want to calculate when will the Somali refugees reach 100,000 in Kenya. And so this is an equation that we need to solve. So we need to set the output, which is K in this problem. We want to set K equal to 100,000 and then solve for what value of T is going to make the value of K equal to 100,000. So we set the left side of the equation equal to 100,000, and that's going to equal our model, which was 68,000 plus 1,300 times T. So first we can subtract the 68,000 from both sides. And so on the left side, that would leave 32,000. And on the right side, we now have the 1,300 T. And now to solve for T, we can divide both sides by 1,300. So T is going to equal 32,000 divided by 1,300, which comes out to 24.6 days. So this means about 25 days after June 30th, the number of Somali refugees in Kenya is predicted to reach 100,000. So now in part B, we want to figure out, well, when are the Somali refugee populations predicted to be the same in Ethiopia and in Kenya? So that means for what value of T are K and E going to equal each other? So the equation that we would set up here is I would set K, which is 68,000 plus 1,300 times T, equal to E, which is the expression 54,000 plus 1,700 times T. And so now we have T's on both sides of the equation. Oh my gosh, what are we going to do? We can group like terms together. So I want to put all of the terms that don't have a T in them, so these two that I just boxed in red, on the same side of the equation. And then I'm going to group all of the terms that do have a T in them on the other side. So for example, I could subtract 54,000 from both sides of the equation. So that would get rid of the 54,000 that was on the right side. And then I'm going to subtract 1,300 times T from both sides. So now I've grouped all of the terms with T on the right side and all of the terms without a T on the left. And now doing the arithmetic, on the left side we have 14,000 is equal to, on the right side, that simplifies to 400T. And so now solving for T, we would take the 14,000, and we're going to divide that by 400. So altogether, that gives us a T value of 34 days. So this tells us that the number of refugees is predicted to be the same in Kenya and Ethiopia about 34 days after June 30th in 2011.